Within any HSE system, the environment component requires a specific lens. We are looking directly at how our operations affect the natural surroundings. Nature operates as a continuous, closed-loop system. Every element is dependent and interdependent on the others to maintain balance. Industrial and commercial operations introduce immediate friction into that balance. By extracting resources and generating output, worksites disrupt these natural processes. Failing to control this friction carries heavy penalties. Organizations that ignore their environmental footprint expose themselves to severe legal liability and staggering financial damages from fines and operational shutdowns. To control those risks, we have to map the site. We will deconstruct common worksite activities, track the exact pathways pollution takes, and categorize how we stream waste. Environmental management is an exercise in tracing causality. By understanding exactly how an operation interacts with the natural world, we can prevent operational failures from destroying the natural assets we rely on. To map the environment, we divide it into two primary categories. The biological environment consists of all living things within the biosphere. The physical environment is everything non-living. This physical environment operates across three distinct spheres. The atmosphere is the air we breathe. The lithosphere is the rock and soil we build on. And the hydrosphere is the water that sustains it all. Both the natural spheres and our industrial systems require energy to function. We pull that energy and the materials we need directly from natural resources. Some of these are renewable, like solar energy or sustainably planted timber, which replenish through natural processes. Others, like coal, oil, and gold, are non-renewable. Once they are extracted and consumed, they are gone. But no resource is more heavily relied upon by both human biology and industrial operations than fresh water. It is an absolutely critical element. This chart visualizes the true scarcity of that resource. While water covers 70%, if an industrial vent releases sulfur dioxide into the air, the release itself is the aspect. The resulting local air pollution, or acid rain, is the impact. This is where environmental management diverges from occupational safety. A safety hazard, like an exposed wire, threatens a worker. An environmental aspect threatens the broader ecosystem. Our strategy is entirely preventative. By identifying and controlling the operational aspects upstream, we eliminate the environmental impacts downstream. When we fail to control those aspects, we generate pollution. Pollution is the introduction of harmful, human-generated substances that contaminate ground, air, or water resources. Pollutants rarely stay where they are generated. They travel outward from their point source via pollution pathways. The fastest of these is the atmospheric pathway. If a site burns its waste, it releases particulate emissions and gases directly into the sky. Those airborne pollutants will eventually settle, extending the damage far beyond the site perimeter. Soil pollution follows a similar path. If industrial chemicals are stored improperly, without containment berms, a single leak allows toxic fluids to leach directly into the ground. Because the physical spheres are stacked, pollution cascades. Contaminated soil acts as a conduit, allowing toxicity to leach deeper until it poisons the groundwater table. Surface water is equally vulnerable. Cement runoff from a construction site or storm water sweeping through an active yard can drain into local rivers, aggressively altering the water's pH. A localized failure never remains local. The interconnected nature of the physical spheres ensures that a single unmitigated leak crosses boundaries and multiplies the environmental damage. To minimize pollution, we have to strictly manage what we throw away. Waste is any unwanted byproduct of a process. It holds zero value for the natural environment. We track these materials from the moment they are generated to their final disposal, using a system called waste streams. The first stream is general waste. This includes materials like building rubble, piles of inert clay, and domestic site litter. These do not pose an immediate toxic threat to health or the environment. The second stream is hazardous waste. These are materials with inherent chemical or toxicological properties, like industrial sludge, chemical residues, or medical waste that cause active detriment. Compliance requires strict physical separation. General and hazardous waste must be funneled into distinct, clearly labeled receptacles on site. If an operator throws a half-empty chemical solvent into a general waste skip, they compromise the system. That single action contaminates the entire bin, turning tons of general waste into hazardous waste. To defend against this, organizations use the 4Rs waste hierarchy. This diagram illustrates our 4 tiers of defense: reduce, reuse, recover, and recycle. The primary goal is at the top: reduce. By implementing proactive management and tighter operational planning, we eliminate the creation of the waste entirely. If we must generate material, we move to the middle tiers: reuse and recover. We find alternative applications for the byproducts within the site before they are discarded. Recycling and eventually final disposal sit at the very bottom. These are the absolute last resorts, utilized only when waste generation and reuse are exhausted. Strict adherence to the hierarchy and clean waste streams proves that effective environmental management prioritizes upstream prevention over reactive downstream cleanup. Environmental management relies on mapping. We identify the operational aspects to prevent cascading impacts from tearing through the natural spheres. On an active site, this theory translates into rigorous daily observation. An HSE professional walking the yard must verify specific physical controls. First, check the waste streams. Verify that physical waste receptacles are strictly separated, clearly labeled, and being used correctly by the crew. Second, inspect the storage. Ensure all chemical and fuel areas utilize secondary containment, known as bunding, to block the pathways to soil and water. Third, audit the response tools. Confirm that fully stocked spill kits are highly accessible near high-risk areas to immediately neutralize accidental fluid releases. Fourth, validate communication. Ensure all external contractors understand the site rules, the waste hierarchy, and their specific environmental liabilities. This last point is critical due to vicarious liability. The law dictates that the primary organization holds the ultimate legal responsibility for the environmental failures of its contractors. Identifying an aspect or a potential impact is only the first step. Knowing a chemical might leak does not tell you the mathematical probability of it happening, or the quantifiable severity if it does. To calculate those variables, you need a formal system. Join us in Episode 10 as we move from observation to calculation and master the mechanics of hazard identification and risk assessment.